Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the types of asynchronous counter, that means up counter, down counter and up down counter. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the details about the synchronous counter. We know that in synchronous counters, all the flip-flops receive the clock signal at the same time. That means the clock signal is given to the flip-flop A, flip-flop B or flip-flop C is at the same time. That is, the separate clock pulse is provided to each flip-flop. Hence, these are faster than asynchronous or ripple counters. Ring counter, Johnson counter is the example of synchronous counter. There are also three types of synchronous counter: up counter, down counter and up down counter. Okay, I hope you all understand what is meant by synchronous counter. The difference is very simple, that in synchronous counter the clock is provided to each flip-flop at the same time. Okay, now let's see 3-bit synchronous up counter. There are two ways we can draw the logic diagram of 3-bit synchronous up counter. That means for up counter we require T flip-flop. Hence we can design T flip-flop by J or equal to K connecting to the 1. Okay, that means J and K are connected to each other. Similarly, we can use directly T flip-flops here. That means flip-flop A, TA, flip-flop B, TB, flip-flop C, TC. We can draw any of the diagram. Okay. Here is what is difference. The JAKA is connected to the logic 1, but QA is connected to the JB and KB. That means when QA equal to 1, then and then only flip-flop B toggles. Okay, then the QA and QB are ANDed together and its output is connected to the GC and KC. That means when QA has the value 1, QB has the value 1, then and then flip-flop C will toggle. I hope you all understand the connections. Let's see once again. Here the flip-flop A toggles at each clock pulse because it is directly connected to the logic 1. But flip-flop B only toggles when QA is equal to 1. QA is equal to 1 because QA is connected to the JB and KB. Okay. Similarly, flip-flop C will toggle only when QA equal to 1 and QB equal to 1. Then and then QA into QB becomes 1. Hence, the flip-flop C will toggle. I hope you all understand the basic connection and concept of synchronous up counter. Let's see once again. A 3-bit synchronous up counter is shown in this figure. All the flip-flops are negative edge triggered. Flip-flop A acts as toggle flip-flop since JAKA is equal to 1. QA output of flip-flop A is applied to JB as well as KB. That means QA is connected to JB and KB. If QA equal to 1, that means if QA equal to 1 at the instant of triggering, then flip-flop B will toggle. But if QA equal to 0, then flip-flop B will not change its state. That means flip-flop B will toggle only when QA equal to 1. Similarly, QA and QB are ANDed and the output of AND gate is applied to JC and KC. It means QA and QB are ANDed together and its output is connected to the JC and KC. Hence, when QA and QB both are having value 1, then JC and KC is becomes 1 and flip-flop C will toggle. Otherwise, there is no change in the state of flip-flop 3. Okay. Now, let's see the operation of the synchronous up counter. Initially, all the flip-flops are in their reset condition. That means QA is 0, QB is 0 and QC is 0. Now, when the first falling edge of the clock occurs, then flip-flop A toggles. That means the flip-flop A toggles and QA changes 1 from 0. That means QA changes 1 from 0. That means there is transition from 0 to 1. Okay. Hence QA becomes 1 now. But QA equal to 0 when the first falling edge of the clock occurs. Hence JB and KB has the value 0. Hence flip-flop B will not toggle. That is QB remains 0. QB remains 0 and similarly QC also remains 0. That means after first falling edge of the clock, the outputs are 0, 0, 1. 0, 0, 1. I hope you all understand the operation when the first falling edge of the clock occurs. Let's see once again. Initially, all the flip-flops are in reset condition. That means 0, 0, 0. Okay. When the first falling edge of the clock occurs, then QA becomes 1. QA has the value 1. Okay. But at the first falling edge, the QA has the value 0. Hence JB is equal to KB is equal to 0. Hence flip-flop B will not change its states. Hence flip-flop B has the value 0 and similarly flip-flop C has the value 0. That means after first falling edge of the clock, we have the value 0, 0, 1. 0, 0, 1. Let's see. During the second falling edge of the clock, flip-flop A toggles again. That means we have the value 1, 0, 0, 0, 1. When the second falling edge of the clock occurs, flip-flop A toggles again. Hence QA becomes now 0. Okay. QA becomes 0. But at the instant of application of second falling edge of the clock, QA was equal to 1. Hence JB or KB equal to 1. Hence flip-flop B will toggle and QB becomes 1. Okay. That means at the instant of second falling edge of the clock, QA has the value 1. Hence JB and KB equal to 1. Now flip-flop B is in toggle mode. Hence it becomes 1. But the output of AND gate is 0 because at the instant of second falling edge, QB has the value 0. Hence there is no change in the output of flip-flop C. That means it has the value at the output 0. After second falling edge of the clock, we have the value 0, 1, 0. I hope you all understand the operation here. Similarly, let's see once again. After second falling edge of the clock, we have the value QC 0, QB is 1 and QA is 0. When the third falling edge of the clock occurs, then QA toggles. That means it becomes 1. But at the third falling edge, the JB and KB has the value 0. Hence it does not changes its state. That means it has the value 1 as it is. Okay, here before third falling edge of the clock, this product is having value 0, hence flip-flop fee does not changes, hence it has the value 0 as it is. That means at the third falling edge of the clock we have the value 0 1 1 0 1 1. Now when the fourth falling edge of the clock occurs, then note that at that time we have the value 0 1 1, sorry, we have the value 0 1 1, that is QB QA is equal to 1. The output of AND gate 1, the output of AND gate is 1 now, that is JC and KC is equal to 1. Hence at the instant of application of fourth negative edge of the clock, hence the flip-flop C will toggle and QC changes from 0 to 1. QC changes from 0 to 1. Okay. Flip-flop A toggles as usual and QA becomes 0. Similarly, QA was equal to 1 earlier to flip-flop B will toggle to make QB is equal to also 1. That means after the fourth falling edge of the clock, we get the value 1 0 0. Okay, I hope you all understand the operation of 3-bit synchronous counter. Thus the counting progresses. After 7th clock pulse the output is 111, and after the 8th clock pulse the flip-flops are toggled and change their outputs to 0. Hence QC QB QA is equal to 0 0 0 after 8 pulse, and the operation repeats itself. This is the truth table for up counter, and it is similar to the asynchronous up counter. Okay, that means 0 0 0 0 0 1 0 1 0 0 1 1 up to 1 1 1, and the timing diagram is also same. I hope you all understand the operation of 3-bit synchronous up counter. Thank you.